So, hello everyone. Today in this video, we are going to study the nuclear reactor. The nuclear reactor is one of the application of the isotope that we have studied in the last video. And what are the isotopes and what is the concept of protons and neutrons? What is the atomic structure? Everything that is the backside of the isotopes that we have studied in this series of the study of electronics. If you haven't watched these videos, please go and watch so that your concepts will get clear in order to make it better understanding for this nuclear reactor. So nuclear reactor, here the word consists of two words. One is the nuclear and another is the reactor. So nuclear word is very similar to the nucleus, right? It's a nucleus. What is that nucleus that we have seen is the part of atomic structure. And reactor means some kind of reactions happening here, right? So yeah, what kind of reactions are going to happen on the nucleus and why this nuclear reactor is so considered powerful? Let's see in this lecture. So yeah, in this slide we are going to explain, in this video we are going to explain what is nuclear reactor, is kind of a definition, and the nuclear fission process. We'll see the working principle of this nuclear reactor, how it works. We'll see the basic two types of it and what are the applications of it. So let's get started with the first slide. What is nuclear reactor? First I will read the definition and then I will explain it. A nuclear reactor is a device that controls and sustains a nuclear fission chain reaction to generate electricity on a large scale. So first of all, whichever device we are studying, whichever system we are studying, we should know what is this output power, like what is this output, what is the purpose of this, why we are creating it. They convert the energy from atomic nuclei into usable electrical power. As I told you, this is nuclear reactor, means some nucleus are involved in the operation. Listen, it's nucleus and it's not atomic reactor, it's nucleus. Okay, we are talking here about the nucleus. So yeah, this nuclei power is going to convert into electrical power, and how, we'll see in this video. So yeah, the nuclear reactor is a device that control and sustain. Why there is need to control and why there is we need to sustain it, we'll see again. So nuclear fission chain reaction. Okay, so what is chain reaction? Chain reaction is certain process which is repeating after one after another. What is a nuclear fission? Nuclear fission is kind of a process, you can say. Like, I have given here the detail of the nuclear fission. Okay, the first one is the neutron absorption. What is neutron absorption? What is absorption? Why we are absorbing in the neutrons? Okay, here in the nuclear reactor is based on one basic principle, that is nuclear fission. Okay, that operation is there, and by controlling of this process we are generating the electricity. And how is this nuclear fission operation is done? A neutron is absorbed by the heavy nucleus, typically uranium 235. So when the principle is like, whenever a slow moving neutron is bombarded or absorbed by the heavy nucleus, okay, example is given as the uranium 235, and why it is, again I'll explain in the next slide. So what will happen after that? If the neutron is get absorbed, nucleus will get split into two or more nuclei. Okay, when the neutron is get absorbed by this heavy nucleus, the same nucleus is getting split into two or more nuclei. So if the nucleus is taken as uranium 235, the small nuclei will be krypton 92 and barium 141. So I hope you remember what is uranium 235 that I have explained in the last lecture. That is, it's a one kind of isotope. And why we are using isotope? Because in the isotope the number of protons and neutrons are not same. So imbalance in between these will cause the will make this nuclei unstable. And because of their unstable nature, we are making them use in this nuclear reactor. Okay, so neutron emission emits additional neutrons which can go on cause further fusion reaction. What we are saying here, there is one nucleus of uranium 235 which is getting absorbed by the externally bombarded the neutron. After that, it is splitting into two small nuclei. Okay, and along with two small nuclei, it is also emitting kind of neutrons. It is also emitting neutrons. So in this process, when the uranium is getting divided into krypton and barium, it will also emit 2 plus 3 neutron, 2 or 3 neutrons. So what this neutron will do, they will go on cause further fission reaction. For the fission reaction we need neutrons, and what is the byproduct of this fission? is neutron. So that neutron is causing another fission operation, and that fission operation will give out additional neutrons, and these neutron will cause another fission reaction. So yeah, you're getting why this is called a chain reaction. Okay, and release of energy. So along with these two and some of the neutrons, it is also energy. It's also giving out the energy in the form of heat and radiation. So yeah, so this heat is very important. This heat we are controlling, and this heat we are converting into electrical power, like usable energy, and some kind of radiation that we are controlling it. Okay, so yeah, this is the nuclear fission reaction. One of the most important thing I want to tell you here, why it is releasing the energy. Why it is releasing the energy? As we know that in the nucleus there are number of protons and neutrons. Protons are having positive charge while neutrons are having neutral in charge. So what is it, what is the, we can say, work of protons is to repel each other, because they are positive in nature, they will repel each other. So what neutrons are doing there, they are making them stay there. Okay, they are combining them. So yeah, in the nucleus a strong force of attraction is there in the nucleus, very strong. So whenever this nuclei is getting break, okay, as you know the first law of thermodynamics, that energy cannot be created nor be destroyed, it just transferred from one form to another form. So if this nuclei is getting break into two nuclei, definitely this energy has to be converted into another form. So that energy is forming into form of heat, radiation, neutrons, like that. Okay, I hope you understood this nuclear fission reaction. Let's get started with the how does nuclear reactor work. Okay, now we are seeing the now we'll watch the we'll see the working principle of nuclear reactor. So what are the basic components of that? Is first one is the fuel. Fuel is something that material is used to produce the energy. And what kind of fuel we are using in the nuclear reactor is isotope or some things or some kind of isotopes which are nuclear fissile, means whose nuclei can be easily split into two parts, releasing out some energy. So yeah, amongst the isotopes, the uranium 235, plutonium 239, uranium 233, these fissile isotopes are available that we can use as a fuel. But uranium 235 is commonly used here because it is naturally available in India, it's abundant in nature, and we have well established infrastructure for it. So yeah, the fuel is uranium 235. Now we have fuel. What is the next procedure? Is moderator. So what is moderator? What it is moderating? It is moderating the fast moving neutrons. So what I told you in the last slide is that when the nuclei is getting break into two nuclei, it is also emitting a kind of neutrons. So these neutrons are very high speed, so we have to slow down their speed. And why we have to slow down their speed? Because slow neutrons are more likely to cause the additional fission events. We want to sustain this chain in order to create the energy, in order to maintain this energy, right? So the fast moving neutrons has to get down their slow speed. Okay, so yeah, we need to slow down their speed. So moderator is used to slow down their speed, and the examples of moderator are like water, graphite, beryllium, etc. we can use here. Now the next one is the control rod. Yeah, so rods are there, and rods are made up of material like boron and cadmium. And what are they controlling? They are controlling neutrons. And how they are controlling? They are absorbing the neutrons. Why there is need to absorb the neutrons? Because if the neutrons are not getting absorbed, there will be a lot many numbers of neutrons available for the next fission reaction, and that reaction will cause next fission reaction. And if the number of neutrons are not getting controlled, the chain reaction will get spontaneous and it might get explosive. So to avoid that, we have the control rod. So yeah, by inserting or withdrawing the control rods, the number of neutrons, or you can say the best word, the rate of fission can be controlled, which is very important thing over here. So yeah, by doing this, we are also ensuring the safety and maintaining the temperature in the reactor core. We'll see the next one is the coolant. Yeah, we are saying here coolant. And what is the coolant is doing? It is absorbing the heat produced in the nuclear fission. As you know that the third product from the nuclear fission reaction is the heat. It's tremendous amounts of heat, so we need to absorb that heat. Okay, what it is else doing, it carries this heat to a secondary system. Why it is carrying this heat to a secondary system? Because we want to convert that heat energy into electrical energy. And how it is that creating? See here, this heat is used to produce a steam for driving turbines. This heat is given to a water, so water will get boiled. The boiled water means the water will convert into steam. That steam is given to the turbines. So what turbine will do? Spin it will spin means the steam energy is now getting converted into mechanical energy, right? Mechanical energy. Now generators are connected to this turbine, so mechanical energy is getting converted into electrical energy. Yeah, that is the basic principle of this nuclear reactor. Yeah, by doing this we are maintaining the temperature also. So which are the example of coolant is water, liquid, sodium, etc. And the last one is the shielding. Why we are using the shielding? Because some radiations are coming out of it, like alpha, beta, gamma, and if they are not controlled they will contaminate it in the surrounding and is not good for the people working over there. So yeah, we are using lead, concrete and water for that matter. So yeah, that's it. Now we'll see the types of nuclear reactors. Basically there are two types: boiling water reactors, which are known as BWRs. The second one is a pressurized water reactor, that is PWR. So name itself, boiling water, means here the boils water directly into this core and it's creating steam. Steam is driving turbines, and turbine is connected to generator, and we are getting the electricity, which is very basic principle that I already explained in the last video, sorry, last slide. What is second one is a pressurized water reactor. Here the world is pressurized. Pressurized water means here we are pressurizing the water, and for what cause? We are letting the water pressurized in the core and it preventing it from the boiling, means we are not converting water into the steam. Why? Because we want to make this steam generator apart from this core, because if we are letting this water boil into inside of the core, the temperature of core will get increased and sometimes it is become uncontrolled. So for that matter we are separating here steam generators, which is transferring heat to a secondary coolant system and producing steam. And then after the operation is same, like steam is driving the turbine and turbine is given to the generator, which is converting that energy into electricity. Yeah, so both are different, but each having their own advantages and disadvantages. For example, boiling water reactor is simple, is design and cost effective. Disadvantages you can say is that there's a safety challenge, because core itself the water is boiling, so yeah, temperature issues are there. But the pressure water reactors, it has enhanced safety, because the coolant and steam generator, these are two separate physical devices, and better control we can put. But the disadvantage is that it is having the complex in design and the maintenance is very costly. So yeah, that was about the types of these two reactors. We'll see here what are the uses of this nuclear reactor. So we all know that primary use of all the nuclear reactor is to produce the electricity for your nation and for that matter. So along with that, research, for the research purpose, it is also used, like it is used to produce the isotopes that we have discussed in the last class. There are tremendous applications of isotopes, which is for medical research and food industries, etc. So yeah, it is also served to produce that isotopes. These nuclear reactors are also used to power the submarine and aircraft carriers. Okay, so in the submarine and aircraft carriers, they use the power electricity from this nuclear reactor. That is also one of the application of this. And yes, nuclear reactors can provide, it is not still implemented, but they can provide heat to industrial process as well. And district heating means instead of the individual building heating system, we can provide a district heating from these nuclear reactors which is nearby them. Yeah, so that could be the application of that nuclear reactor. There are total 22 nuclear reactors in the India, and the total capacity of them is 7.48 gigawatt, and it is about 3 to 5% requirement of all the electricity of the nation. So yeah, the thing is that India has abundant source of thorium-232 isotope, and thorium-232 can be converted into uranium-233 by bombardment of slow moving neutrons, and uranium-233 can be used as a fuel in the nuclear reactor. So yeah, the scientists are working on that, and if they get successful, we'll have a tremendous source of electricity in our nation. So at the end conclusion, I can say that yes, nuclear reactors are very safe and reliable energy sources, and they are not contributing any kind of greenhouse effect, and zero emission they are having. And yes, this is very critical for the India's energy security. This is a demand of India for the higher energy conversion, and it is using that. So yeah, that is all about the nuclear reactor. I hope that video was very informative for you, and thank you so much for watching. Thank you.